In this video, I want to talk about composite and inverse functions. So we're going to start off by talking about what we call a composite function. And a composite means basically you're going to compose two functions together to form a new function. So let's take a function f of x, and then we have a second function which we'll call g of x. And when we compose these two new functions, we're going to get a third function which we will refer to as h of x. So if we want to talk about the composite, generally speaking, the composite is written as f of g of x. And this notation, the fog notation, you see some people call it, this right here is read as f of g of x. So f of g of x. And what it really means is, another way, a simpler way to read it is to take the second function as written g, you're going to replace every x that you see in f. So basically the input for the f function, which we can write it like this now, f of g of x. This is another way to write this, and it's a common way to write it and to see that what you're doing is, remember, when you have f of x, this is the input. So what this says is to input the g function, input g of x for every x. So let's do an example with this. Let's take the function, let's take a function that we have f of x is equal to x squared minus 9x plus 18. Let's take the g function, and this will just be x minus 3. I can compose these two functions and form the composite of f of g of x. And again, I like to write it in this notation here because it's easier for me to see. But you can leave it like that and realize you're plugging in the g function for the f function. But I like writing it as f of g of x like this. So this tells me I'm plugging in g into every f function, every x and f. So we have for the x squared. So I'm just going to write where I see x's in. I'm going to open parentheses for those. I'm going to come back to them. This is squared minus 9. And again, I see an x here, so I'll open parentheses there. Plus 18. And in all those parentheses, those were supposed to be x's. But now I'm telling you that the x value is the g of x function. That's the new input. So I'm going to type in x minus 3. I'll put in x minus 3 here and x minus 3 here. And so now all I have to do is do the operations that are around the parentheses. And I'm going to do x minus 3 squared. And I'm going to do x minus 3 squared. I get x squared minus 6x plus 9 for the first set. Minus, I'm going to distribute the 9 here. I'm going to get 9x, negative 9x plus 27. And then plus 18 in the back. And so now, when I clean all of this up, I'm going to add x squared. I only have one x squared. I have negative 6x minus 9x. That is a negative 15x. Then I have 9 plus 27 plus 18. 9 plus 27 is 36. Plus 18 is 54. So here's the final answer. And this is the composition of f of g of x. Now, realize this. I can go back and do the composition of g of f of x if I want to. And one thing that you may see asked a lot is, are the compositions of f of g of x the same thing as g of f of x? So let's see real quick. Is the composition of f of g of x the same thing as g of f of x? Are these the same things? So this is really saying take the f function now, and for every x in g, I'm going to plug in the f function. So the f function is just, again, wherever I say x, I'll open parentheses, and I'll do minus 3. And so for this, I'm going to plug in the f function, which is x squared minus 9x plus 18. And when I clean it up, I get just x squared minus 9x, and then 18 minus 3 plus 15. So the question of is f of g of x the same thing as g of f of x? Well, we can see that from just doing this one example that they are not the same. They are not the same to each other. So what that really means is that these properties are not commutative. So we're about to get to the special case then if they are the same. That's what we're going to look at in our next video. So let's do an example where we do it from a graph. And again, all a composite means is you're going to take the input of one function and plug it into the output of the new function. So you take the output of one function and you'll plug it into the input for the new function. So for this particular problem, we're going to do f of g of 3. And look, notice that my f function is the blue function here. Here's f of x. And the g function is the red function. Here is g of x. So this says, another way to write this, and a simpler way to write this would be to look at it from this point, f of g of 3. So this says to evaluate g of 3 first. So we go on our graph and we look at the red function when x is equal to 3. That's what this means. This means that x equals 3. Well, x is equal to 3. What is y equal to? So when I go here, I see that y is equal to negative 2. So basically this says evaluate this at that, and this is negative 2. So now evaluate the f function at negative 2. So go on here and look at f of negative 2, which is the blue function, at negative 2, and that's there, and we see that that's equal to 1. So all of this is just equal to 1. Next one, g of f of 2. So again, another way to write this, and a simpler way to probably write this, is to write it as g of f of 2. And this says to evaluate f of 2 first. Well, f of 2 is sitting here at this value, which is negative 3. So this is just negative 3. And now, so I evaluate the red function, g, at negative 3. And I evaluate g at negative 3. I get this here. And that's equal to g of negative 3 is equal to negative 1 for the y value. This next example involves finding the composition from a table. And so when we do this from a table, same concept as a graph. You're going to, again, it's easier to rewrite this equation or rewrite this composite function as f of g of 8. And so what this says is to start with g of 8 first. So here's your f function, and here's your f function, here's your g function. Here are the x's that are available to you. So I'm going to go to g of 8, so I'll say g, I'll go to the x is 8, g of 8 is equal to 4. And now I need to evaluate this function at f of 4. So again, go to the f function, go to your 4, f of 4 is equal to 4. Here, rewrite it again as g of f of 5 first. And so again, this I'm going to go to the f function first and look at f of 5, which is 0. And then from there, I'll evaluate the function g at 0, and g of 0 is 9. And on this last one, it says f of 0. So what that means is you start off with the f function. You're going to evaluate at f of 0 first, and then whenever you get there, you'll evaluate the f function again at that new number. So we look at f of 0 first. F of 0 is 7. And now, so I'm going to evaluate f again, but I'm going to evaluate it at 7 this time. So f of 7 is 1. And that's how you read it from a graph and also a table. So it's very simple. Just remember, if you rewrite it, it's a lot easier to see it.